why this endless thing is useful? Okay, just imagine. You know that there are unlimited number of prime numbers, right? Am I right? How do we prove it's unlimited? Look, if the first number, prime number is P1, second prime number is P2.
A prime number needs to be an
P3.
odd number.
If there are limited number of prime numbers, let's say Pn, right? Up to Pn. And how about if we times these together?
That's limited.
Yeah.
I know. I'm proving that it's unlimited. So let's assume the opposite. It's limited and there are n prime numbers. P1, P2, P3 up to Pn. And let's times it together plus 1. Obviously, this number is not divisible by any of these, right? Am I right? So this is also a prime number. We just assume there are n prime numbers, but now we found another one. So what does it mean? The assumption is wrong. The assumption, what's the assumption? There are n prime numbers. This assumption is wrong. Okay, so what does it mean? It means we have unlimited number of prime numbers. Okay? Okay.
Wait, but you're saying P1, P2, P3, but you only have n two times together and plus 1.
That's right, and this
Yeah,
number
you
is a
only
prime number.
Yeah, you only have n to multiply by.
Yes.
And that's limited because you only have n.
Yes, sir. My assumption is that, okay, let's assume there are n prime numbers.
Yeah.
And then I just found out this number, plus 1, comes together plus 1, is also a prime number.
Yeah, that's only one more.
One more. Okay, so there's only one more. So it contradicts, it conflicts with the assumption there are only n. Actually, there are n plus 1. And I can keep doing this, keep adding this, keep adding this. So that means that...
Wait, what do you mean keep adding?
Okay, I'm assuming there are n prime numbers. But now I found another one which is not part of this n. Okay? So I have one more number here,
Yeah,
which
but-
is a prime number.
Yeah, but how do you add another one?
This is another one. This is another one.
Yeah, so you times that another one with the other n.
Yes. So this number, this
Yeah,
number
but-
is a new prime number.
Yeah, but when if you test it out, the first prime number times the second prime number, what about plus
2
1?
times 3.
Look, 2 times 3 equals 6, plus 1 equals 7. You missed the 5.
That's okay. Okay, so let's assume there are only two prime numbers, right? Let's assume, okay, we want to prove there are only two, they are limited prime number, which is 2 and 3. Now I'm telling you, 2 times 3 plus 1, this is obviously a prime number. 7.
And then 2 times 3 times 7.
Okay, so we found another prime number, which is 7. So the original assumption is wrong. They are not just two prime number, because 7 is another prime number. My original assumption is there are only n prime numbers. Now I found another one number which is prime number. So it contradicts the original assumption. So the original assumption is wrong. The opposite is correct, which is there are unlimited number of prime numbers.